Hey everybody, this is a video for activity 6.3 out of the second physical science book, so it's PS2. And activity 6.3 is molecules in motion, liquids and gases. So if we back up a little bit to 6.2, we explored solids and how those molecules are moving within a solid. So in 6.3, we're going to take a look at liquids and gases. Our learning target for today is we're going to investigate the relationship between temperature, kinetic energy, thermal energy, and the molecules in liquids and gases. So obviously, if you're watching this video, something's going on. You might be absent and you're trying to get the lab caught up at home. You might be in a situation where you're unable to do the lab because this lab does require Bunsen burners. If you didn't have your safety contract in or safety agreement, you will be doing the alternative. It might be, for other reasons. But here's my point. So when you look at the procedures, and again, you're in your online textbook, or you might be in your physical science textbook if we go back to physical science textbooks. But A says fill a beaker with 150 milliliters of water, and it says use a thermometer and measure the temperature of the water. Well, you're doing a virtual lab. You're not doing the actual lab. So there's no beaker to fill with 150 milliliters of water. If you're at home, could you do this on your own? You could. Just get your parents' permission, but you just need heated water. And you could just take water right out of the faucet, just let it run for a little bit and get it really, really hot and really, really cold. So this one says cold, but down below it's going to ask you to use hot water. You can use tap water. You don't need to use the stove. But just again, get your parents' permission, and you would need some food coloring. All right, so for A, you're not going to be able to do. You don't have a thermometer. Well, you might have a thermometer at home, but you don't have to do it because you're not doing the actual lab. But look at B. It says use a pipette to carefully add 1 drop of food coloring to the beaker. Do not stir. Observe what happens to the food coloring. Write down what happens to the food coloring. Look at C. It talks about hot water. It says use the thermometer to measure the temperature. Again, you don't have to do that. But if we look at D, it says use a pipette to carefully add 1 drop of food coloring. Do not stir. Observe what happens to the food coloring. Write down what happens to the food coloring. So you are going to do D, and you are going to have to do B. What I'm going to do is I'm going to show you a video that I created. So, I'm not showing you someone else's work. This is a video that I made a few years ago, and you're going to record your temperature. So during the video, you can pause the video every so often, come back and complete your observations for B, which is what's happening within the cold water, and then D, what's happening within the warm water. All right, so I'm going to pause this video. I'm going to pull up the other video that you're going to be watching then. All right, so here's the video. I'm going to go ahead and let it play. H is for hot. The C is for cold. There is some music going on, so while this is playing, please complete B for the cold water and D for the hot water. We'll just pause those so you don't hear all the music. So you can see in the cold water what's happening, and it's very different than what's happening in the hot water. So the hot water I actually heated up with the beaker, so it was very, very close to boiling. In fact, it was boiling before I took it off. It's probably about 200 degrees now. If we're looking at Celsius, remember water boils at 100 degrees Celsius, so it's probably at about 90 degrees, 95 degrees. So you can see that there's a definite difference. So the video's got about 30 more seconds. If you need to pause the video, please pause this video and complete your observations in the book. If you're wondering what the cold water is, I did have it extremely cold. It was in the fridge, so it's not going to be freezing 32 degrees Fahrenheit, or it's not going to be 0 degrees Celsius, but it's getting down there. It's pretty close to freezing. So I'm going to pause the video there, and you can go ahead, pause this video and complete your observations, and we'll start up again in the textbook. All right, so you should have your observations done for B and D. Now, E says, watch a computer simulation that demonstrates the molecular motion of a liquid at high and low temperatures. Do the molecules of the liquid move faster at high or low temperatures? And then you're going to watch a computer simulation for a gas. Do the same thing. Do the molecules of the gas move faster at the high or the low temperature? So I'm going to play these back to back. Again, if you need to pause this video so that you can make observations in your book, go ahead. So I'm going to first play the liquid, then I'm going to play the gas. So again, make sure you're taking observations for E and F. So I'm going to pause this video a little bit, and I'm going to run those simulations. All right, so here's the heating of molecules of a gas. Again, you're supposed to be making observations and answering this question. Do the molecules of the motion, or do the molecules of the liquid move faster at the high or the low temperatures? So as you can see right now, we're at a cold temperature. But watch what happens if I start to slide up and heat up the air in the gas. So this one right here is the gas, so it's actually for F. So as you're recording this, make sure you're answering F. This is for the gas. I was going to start with the liquid, but this one popped up first. So you can see in warm what the molecules do, and you can see in the cold what the molecules do. Now let's go back and let's do E. This is for the liquids. So here you can see in cold temperatures, and we start to heat it up, heat it up, heat it up, heat it up. So again, you're answering the question, do the molecules of the liquid move faster at the high or low temperatures? Yeah, this is for the liquid, high temperatures, low temperatures, and here's the gas, low temperatures and high temperatures. So what you're going to be doing next, after watching the videos and watching the computer simulations, what I would like you to do is finish up the making sense questions. Do the water molecules collide with food coloring molecules? So if you need to go back into that part of the video and rewatch that, go ahead. Now, question number 2, if the water molecules move faster, will they collide with the food coloring molecules more vigorously and frequently? So go ahead, pause this video and answer that question. And if you need to go back to the part of the video where I showed you the 2 test tubes, or not test tubes, but 2 beakers and the water being heated, or the food coloring in the heated one and the cold one, please do so. Once you get done with the first 2 questions, do the next 2 making sense questions. 3, if the food coloring molecules are hit more vigorously, will they spread out faster? Then why does the food coloring spread out faster in hot water than in cold water? So go ahead and pause the video and answer these 2 questions. All right, so you've had a chance to answer those 2. There's one more question I need you to answer. Number 5 in your book. Do water molecules move faster at high temperatures or at low temperatures? So now that you finished this lab, you should be able to correct these when you come back to class, or if you're going to be late, you're going to, you can always run them by me and ask, hey, Mr. Attune, are these done correctly? So I can come back and we can take a look at them. We can talk about them before the test. Or if you continue to watch this video, I'm actually going to go through the answers right now. So number 1, do the water molecules collide with food coloring molecules? Absolutely. The water molecules collide with food coloring molecules. You can see that in the water, especially the heated one, the molecules are moving much, much faster. So number 2, it says if the water molecules move faster, will they collide with the food coloring molecules more vigorously and frequently? So when you watch those 2 beakers filled with one hot water and the other one's filled with cold water, and if you remember, the one with hot water, the food coloring spread out everywhere. And that's because the hotter the molecule is, the faster it's moving. So the water molecules are hitting it faster, it's colliding more vigorously, and it's spreading out. The cold, the molecules are moving, just not nearly as fast. So the food coloring does not spread out. So we actually use the food coloring within the video so you can actually see the molecules moving. If the food coloring molecules are hit more vigorously, will they spread out faster? Absolutely. They're going to spread out faster. So that's very similar to this question, is will the food coloring molecules more vigorously and frequently collide with the molecules if they're moving faster? Yes. And what's the result? Food coloring spreads out very fast. So that demonstration with the two beakers shows you that the molecules are moving faster. So why does the food coloring spread out faster in hot water than in cold water? Again, it all comes back to the molecules. Warm water, the molecules are going to be moving a lot faster than in cold water. So the food coloring spreads out faster. So just think, and it's not just liquid. It's harder to do with air because it's harder to see it. But even if the air was warmer, you could see that the molecules are moving faster. But in the liquid, same thing. Molecules are moving faster if they're warmer. And then the last question is right here. Do water molecules move faster at high temperatures or at low temperatures? They move faster at high temperatures. So questions 1, 2, 3, and 4, they're all very, very similar. And they all want you to get to the idea that when an object is warmer, whether it's a liquid, whether it's a gas, whether it's a solid, if it's warmer, the molecules are moving faster. And we use the food coloring, we use the water so that we could physically see it happening. So again, as always, if you have any questions about this activity, please let me know and ask questions. Thanks.